Everyone says a 0.4 millimeter nozzle is a perfect nozzle size. But what if it's holding your printer back? What if you can print 40% quicker, get stronger parts, and barely lose any detail? Just by swapping out a tiny piece of metal. I'm Brian DeLuca, and today we're putting a 0.04, a 0.06, and a 0.08 millimeter nozzle to the test. They're going head to head on a Bambu Lab A1. Same models, same filament, and the same environment. And today we're looking at surface quality, speed, bridging, cooling, dimensional accuracy, and strength. Let's see if bigger means better. For this test, I'm running the BIQU Panda Hotend with a hardened steel nozzle in 0.4, 0.6, and 0.8 millimeters on the A1. And a quick note, BIQU was kind enough to send over these Panda Juicer Hotends with the hardened nozzles for me to test. They didn't script this. They didn't review this. We're just testing the same way I test everything. Now for the important part. We're using the same filament, the same settings, the same print orientation, and even the same room temperature. The only variable we are changing is the actual nozzle size. We're running 4 standard tests. First a calibration cube, and of course a benchy, then a detailed model, and we're gonna run one of the bridges we designed for strength testing that we're gonna put in our force meter. We're gonna track print time, material use, surface finish, and structural performance. Now let's get them tested. Okay, let's throw on some safety goggles because we are going to be doing some strength testing. Now, let's just talk about the test we're going to look at. We actually have a calibration cube, a benchy, we have the Goblin head, and this is very, very textured. So we're going to be able to see the detail it performs, and we have our bridge that we're going to see how much force it takes to break, which is one of our standard testing for materials. So let's start with the calibration cube and see how they stack up against each other. Oh, wait, before that, let's look at the poop, because the poop could tell you a lot right off the bat. So you can see 0.04, the spirals are pretty tight, and they get much wider in the 0.6, and they get even wider, but not as noticeable in the 0.8. But you can see, it's, the extrusion is getting thicker and thicker as we go up from a 0.4 to a 0.6 to a 0.8 millimeter nozzle. So let's look at the calibration cubes. Here's our 0.4 millimeter. It looks really, really clean. If I compare that with the 0.6, you can start seeing some layer lines, very visible. And if I compare that with the 0.8, you're seeing a lot more of the layer lines. Now let's look at the benchy. So this is the one from the 0.4. Looks pretty clean. I want to show you the top of the roof because that is what really got my attention. This is the top of the roof from the 0.4. There's the top from the 0.6. So it's becoming much more noticeable, the texture. And here's the top, and this benchy didn't come out right. It looks like it shifted a little. There's the top from the 0.8, but I wanted to have a fair test. So I'm giving you exactly what printed. And like I said, you can see this benchy shifted a little at the top. You see right there, had a little layer shift. But overall, you could really see the difference in the detail quality when you go from 0.4 to 0.6. I didn't even clean this up. I had some stringing. Now here's the real question of detail, is these Goblin heads. Now this is the Goblin head with a 0.4, and you can see the skin texture. It looks pretty good. And you can see the top of his head, you can just see the skin texture, right? And you can see a little bit of layer lines, but not much. But watch what happens when we move up to the 0.6. You can start seeing much more layer line. And the same thing goes when you go to a 0.8. It's even more noticeable. So we see the details starting to diminish as we go bigger, which we sort of knew. Nothing unexpected. Now it's time for the force meter. Now, like everything here, they were all printed with the same settings. The only difference was the nozzle size. Okay, we're going to test how much force in newtons it takes to break our bridge. Okay, let's test the bridge that was printed with the 0.4 millimeter nozzle. Now we're zeroed out. Let's see how much force it takes. Okay, we heard our first crack. Let's just drive it all the way through. That pretty much destroyed that bridge. Look at that. Completely cracked. Okay, now let's test the 0.6 millimeter nozzle printed bridge. Now, as you can see, printed with the exact same settings, exact same amount of walls, and you can see the 0.6 held up much better. This is the 0.4, 0.6. You can actually even see there the difference in the layer lines. Okay, now let's test the bridge that was printed with a 0.8 millimeter nozzle. This one should be the hardest to break. Let's go. Are you ready to tell you right now? Oh, it's maxing out. It maxed out the force meter. So this is the 0.8 millimeter nozzle. You can see very little damage in comparison. Oh, that's pretty close. This one's definitely dented more, but that's the 0.6. And that's the 0.4. So we can see structurally the 0.8 millimeter nozzle definitely held up better. I heard the force meter beep, which means it maxed out. So let's take a look at the results of how much force it took to break each one of these bridges. That was interesting. Now, we knew the 0.8 would be much stronger. Now, the 0.4 millimeter nozzle took about 28 newtons of force. The 0.6 millimeter nozzle took about 39 newtons of force. And the 0.8 millimeter nozzle took 51 newtons of force. So it actually took double the amount of, oh, I shouldn't say double, almost double the amount of force that the 0.4 millimeter nozzle took. I mean, not quite double. This was 28, this was 51, but it took a lot more force, over 22 newtons more of force. Now let's look at how long, how much, and how much material it costs to print each one of these test sets. So let's look at a breakdown of how much filament and how much time each one took. As you can see, when we printed all the items, the 0.4 millimeter nozzle took 4 hours and used about $1.76 worth of filament, about 87 grams of filament. I also put it in meters in case you're into measuring your filament in meters. And you can see it went exponentially up all the way to the 0.8 millimeter, where the time dropped significantly. I mean, it went from 4.5 hours to 2 hours and 50 minutes. So we saved an hour and 40 minutes by going to a 0.8 millimeter nozzle. Now, also the cost did jump from $1.76 all the way to $2.30, and we used about 25 grams more of filament. So we did see things exponentially jump up in terms of materials and cost, but we saw it did save an additional amount of time. When we did the benchy only, it was really interesting. It went up, obviously, except for time. Time was cut down. But if you look at the 0.8 millimeter nozzle, it was actually cheaper in terms of cost. It was 27 cents versus 29 cents. And it used slightly less than 1 gram less of filament on the 0.8 millimeter nozzle, as well as less meters of filament. Now, granted, I'm sure there is some plus or minus percent variation in the slicer. This was sliced in Bambu Lab Studio. So it looks like they may have been roughly the same. It's a very small margin of change between the two. So, but it was interesting to see that it actually went down for the 0.8 millimeter nozzle versus being higher. So if you want these two charts, I will have them on my site where you can download them for free. I'll link them in the description below, as well as links to the BIQU Panda juicer Hotends that we use for testing in this video. Now the question is, should you upgrade from 0.4 to maybe a 0.6 or a 0.8? I think everyone should have a few different size nozzles in their 3D printing workflow. And you should really consider a 0.6 millimeter or 0.8 millimeter nozzle if you want faster print times, if you care about strength versus micro details, if you print large objects regularly, or if you even print with abrasive filament. Nozzle size will completely change your print behavior and your 3D printing workflow. It's not just a number, it's a workflow shift. But here's the real question. Have you been underusing your printer the whole time? Because that 0.4 millimeter nozzle may not be the best fit for every project. Drop your current nozzle size below. Are you team 0.4 millimeter or are you looking to go bigger? For more on 3D printing, DIY, or maker projects, like and follow Maker Build It, and remember, keep on making. Oh, and remember, nozzle size doesn't just change your detail, it changes your entire 3D printing strategy.